does this series converge? Clearly we're talking about the integral test, and if we write this series as if it was a function like this, and we answer yes to the following three questions, then we can use the integral test. Just to review, those three questions are, is this positive? Yes, it is. No matter what x value you plug in, it's positive. However, the only x values we need to worry about are positive ones anyway, okay? So, yes. Is it continuous? Yes. There are no discontinuities on that. Is it decreasing? Yes, because as x gets larger, the denominator gets larger, so the fraction itself gets smaller. This function is continuous, positive, decreasing. I set them in a different order than I did them a minute ago, but it's those three things. Therefore, we can use the integral test. There are lots of other tests we're going to learn in the process of doing this unit, but here goes the integral test. So what I want to know is, if I did this improper integral from 1 to infinity, 1 over x squared plus 1, then dx, if I was able to get an answer, like an answer not infinity, then I would know that this converges, and because this converges, corresponds to this, the series would also converge. What would it converge to? I don't know. If I added up 1 going in here plus 2 going in here plus 3 going in here all the way to infinity, what would I get? I don't know. But I can tell you for sure if it converges or diverges based on what this does. Okay? So let's keep going. First thing you do is you look at this and you say, I can't go to infinity, but I can pretend to with the limit. So limit as b approaches infinity from 1 to b of 1 over x squared plus 1 and then dx. And hopefully the structure of this looks a little familiar, a lot familiar. This is going to be an arctan situation. So let's just go ahead and integrate it. You might be tempted to look at this denominator and try some u substitution and say, well, the derivative of that denominator is 2x. I need a 2x in the numerator. I don't have a 2x. I don't have an x at all. U substitution is out the window in the traditional sense. This is arctan. This is totally arctan, where u is x and a is 1. Formulas for that. Not going to review them in this video. We're just going to keep moving. So arctan of x over 1 from 1 to b. Okay, good to know. Let's keep moving. Using the fundamental theorem of calculus, we're going to plug in a b, plug in a 1, subtract them, see what happens. Clearly we're taking a limit at the same time, so the limit as b approaches infinity of arctan of b minus arctan of 1. There we go. All right. Let's keep going. Think about this. Arctan of b as b approaches infinity. Arctan is a question. The question is, at what radian value will I have an output, at what angle, what radian value, will I have a tangent value of 1 or infinity? Okay, so thinking about the unit circle, at what radian value would I have a tangent value of infinity? It's up here where it's undefined, and that is at pi over 2. So, pi over 2. Okay? Tangent of pi over 2 is undefined, which graphically, let's go from a different graph perspective here. The graph of tangent looks like that. And that asymptote occurs at pi over 2. We're approaching infinity. Just saying. We'll never get to infinity, but we're approaching it, which is the point of a limit. Okay, back on task. Arctan of 1 is a question saying, at what radian value, what angle measurement, will I have a tangent value of 1? That happens here. That is at pi over 4. So minus pi over 4. So here's the deal. I can keep going with that, and I will. And I will talk while I keep going with that. This is pi over 4. Pi over 2 minus pi over 4. Pi over 4. I got an answer, meaning I did not get infinity. So therefore, this converges. The integral converges, so the series converges. What does the series converge to? I don't know. Does it converge to pi over 4? Most likely not. Be a rare coincidence if it did, but I know it converges because the integral converges. I'm going to write that down. I want to be really wordy with this. I want to just like write it down in all of its disgustingness. All right. I'm going to get all technical with it because, yeah, if it was free response, I'd want to. Because f of x, which we've defined above, is positive, decreasing, and continuous. I am abbreviating a lot. Positive, decreasing, and continuous. We used the integral test. The integral converged. It converged to pi over 4, but we don't care what it converged to, just that it wasn't infinity, or negative infinity, one of those crazy things. The integral converged, so the series, and I'm just going to be all crazy with it. You don't have to do this, but I'm going to write the series again because I just like to put it in full context. It's just me. So the series also converges. Got it. Bad handwriting, but we got it. And it kind of slopes downward, so it has a negative slope.